So friend, in this sessions we are going to learn how to read the schematic diagrams of the type C laptop motherboards, and what are the test points that we are going to learn in this sections. So I open here LCFC boards. The board number is NMD011. Okay, this is basically used for the Lenovo laptops, and we'll straight away go to the power sequence of the type C connectors. So first we'll go to the second page. So this is second page is basically the block diagram. So the CPUs is a tiger leg, okay, and these are the all this connections to the CPU. Like here is an embedded controller, that is a SIO. Okay, so here is a SIO, and this is a bias, 32 MB bias. Okay, and the SIO bias, CPU and the SIO is connected via this ESPI bus. Normally the previous laptops are work on LPC bus, but this newer generation laptop works on ESPI bus. Okay, and we'll go to the power connector first. So we'll scroll the pages. So this diagram is 81 pages. So we'll scroll the pages and we'll see where is my DC connectors. Even then we'll go here, and yes. So okay, this is my type C connectors. So here is the type C connectors. Okay, and this connector have the all the connections or the signals are there, like V-bus, that means the supply. Then the CC line, CC1 and CC2 will be there. There's two CC line, and then RX, then TX. This is a RX, then TX, ground, and D minus D plus, that is for USB 2, and the next signal is SBU1. Okay, so these are the signal which are connected to the uh, from connector to chip. Okay, so but in this sessions we are going to learn only the power delivery system, how the power flows from type C connector and how that voltage going inside in the circuits. That only we are going to learn in this sessions. So first of all, when we connect the adapter, then the CC line communicate, and then the CC line goes to the next sections. So what we do is we'll go through this concept, because you can see in our earlier video that we explain all the concepts. So here is the type C connectors, and the type C connectors, the power connected, and then power is directly communicate with the type C controller chips, and there are power path. There will be the two MOSFET. So this is my output signal. So I'll select this, copy, and then we'll come here. Okay, so the V bus is connected to the here, and then why there are two coils, the small coils are there, then the name of the V bus will be changed. So here is a V bus underscore TBT underscore connectors, and after that coil, this name is become a TBTA underscore V bus 20. And if you're going to check voltage over here, you should get a 20 volt here. Okay, so it will pass here, and what I'll do is I'll select the next thing. I'll leave it this, and I will select this. I'll copy this, I'll come here, I'll cancel this, then I'll paste here like this, then next, okay. So these are the two load switches. Okay, so these are the two load switches. So here you can see in this concept, you can see here in the concept, that when the power pass, there is a there is a power path, there will be the block the power, and there will be the MOSFET, and this MOSFET will be triggered by this type C controller chips. And when they trigger the type C controller chips, when he receive the power, when the CC line communicate and everything is okay, then it will give the trigger, and then the voltage will pass from here to here. So in this schematic, you can see here is a MOSFET and the voltage come here. So here will be 20 volt, and that 20 volt will be passed via this two MOSFET. Here are the two MOSFET, okay, and then the voltage will pass this fuse. Here is a fuse, here should get a 20 volt. But before that, if this MOSFET get triggered, then only this voltage will be passed. So now who trigger this two MOSFET? This two signal. Here are the two signal, this two signal, and this two signal is coming from the type C controller chips. So this two MOSFET triggered by this type C controller chips. This type C controller chips trigger this two MOSFET, then only that voltage will be passed, and it's going into the buck boost converter. Okay. So what we'll do is we'll take select tools, we'll copy this, copy. Now that the signal is coming from page number 43, so we can go straight away page number 43. Otherwise, we can select the signal, and we can paste here, and then we can search like this, Okay, okay. So here we are in the page number 43, and this chip is a type C controller chip. The location of the chip is a UB7, okay, and the chip name is number is SN2001024YGBR. So this is a chip number. So what happen is, once this chips uh, receive this voltage from this TBT underscore VBus at here, then what happen is this chips communicate via the CC line. So here are the CC line, you can see here the CC line. This is going to connect, communicate, this signal is going to connect with the type C controller connectors. Okay, so from the adapter to the chip they communicate, and then this chip will send out this two output signal, which will trigger those MOSFET, and then voltage will arrive here, that V in 20, that here you will get a 20 volt. Okay, so you should get here a 20 volt. First it will come here, and then once it triggered via this A4 and E8 pin, then voltage will arrive at here. Okay, and but before that, in this chips, how you will find whether this chip is working or not? This simple. Once this chips receive this 20 volt at here, then this chip have the three linear regulator. So this is the first linear regulator H3 pin, where the LDO you will get a 3 volt here. Then here is a 1.5 volt, here is a 1.5 volt, and here is a 3.3. So this is a linear voltage come out from the chip. If this voltage is coming, then this chip is working, otherwise there will be problem. Okay, and this chips require a 5 volt, but this 5 volt he will get afterwards. Once that buck converter start, the 5 volt buck converter start, then only this chips get a 5 volt. Okay, so now once this chips get a trigger, CC communication take place, and this V in T20 volt is come out, and then this voltage is going to the buck boost converter. So where is the buck boost converter? So this is on the page number 66. So we'll come here at page number 26, and you can see here this is V in 20 voltage. Here is a V in 20 voltage, so 20 volt will be here, and then this voltage pass via this coil coming here, this current sensing resistor. Here is a current sensing resistor, and then here is a chip. Location of the chip is PU2. Okay, and the chip number is BQ25710SRSNR. So this is a QFN 32 pin chips. So So what happen is, so once the voltage arrive at here, then this V bus voltage is going to the this chips from here at its V bus, and then here will be two current sensing resistor. Then the SM bus will be started. Here is the SM bus which will communicate, like you can see in the concept. So you can see in the concept, this type C controller chips are the SM bus. SM bus is basically a two-wire communication between the two chips. So here the all ports are connected to each other. Each port have the different addresses. So the SM bus is connected to the type C controller chips, then the battery, and this buck boost converter, as well as to the SIO. So this communication will take place, and then this voltage will be switched by this buck boost converter, and that buck boost converter convert that 20 volt into 30 volt. In this circuit, here with the two MOSFETs are here. Here with two MOSFET, the Q3. This is a dual MOSFET which triggered by these chips. So the 20 volt will coming here. So the 20 volt you will get here, which is coming here, and then both the MOSFET started triggering. Then pulsating AC volt will be generated here. So here is a coil. Okay, so here is a coil, and then this AC voltage will pass here, and then what happen is this chips dry upper gate, and then this voltage will pass from here to here. So, and these are the filter capacitor, they will filter all the voltage, and here you will get around 13 volt, and that 13 voltage pass output. Okay, so in this way this circuit work, and the control by these chips, this you have to remember. Then now the question is, how will find whether chip is working or not. Simply, if your voltage is coming here at 20 volt, but you are not getting here output voltage, here you are not getting output voltage 13 volt or whatever, it's a depend model to model, but normally it's come 13 volt, or some model is 11.1 volt. It's depend battery to battery. So suppose the output voltage is not coming, then you have to come in the chips, and you have to check first V bus, then you have to check this AC in and ACP the same voltage, VDA voltage, that is a 5 voltage, and there will be another voltage is, so oh wait, yeah, this one REGN voltage. Okay, so here you will get a voltage that is a 6 volt you should get here. So all this voltage should be there. In some model it will be 5 volt, but some voltage should become here. So okay, you can check here a 5 volt. Okay, and then here is a communication protocol. This pin number 12 and pin number 13 is a SM bus communication protocol. So SM bus communication protocol which communicate with the type C controller chips as well as with the SIO, and this is the AC in signal which detect the AC and communicate with the SIO. Okay, so this all the signal you have to check, and if all the signals are coming, like if input voltage is coming, AC in is coming, RG in is coming, but still output is not coming, then probably this chip is bad, so you have to replace the chip. Or sometime this MOSFET is also bad. So here is the two sets of MOSFETs are here, and here are the two sets of MOSFETs are here. So in this way this circuits work. And here is a battery. So this voltage is called the system voltage. Okay, and this voltage is called the battery voltage. So this is the output voltage, this voltage is going to the battery. Okay, and now if the adapter is absent, so here this AC in signal will be 0. So here is the AC in signal, the SM bus will communicate, and the AC in signal will be 0. And then what this chip will do is, the voltage will pass. So you can see here the MOSFET Q5. So the battery voltage will be passed via this MOSFET, was via this diode, and come across here's output. So when the laptop working on a battery, at that time voltage coming from this side, and when the laptop working on the adapter, the power is coming from this side. So you have to remember this. And when to charge, when the battery require a charge, at that time what happen is, so if the battery need a charge, then battery SM bus will communicate with each other. The battery on the page number 65, so we'll come here at page number 65. See where is the battery connector. So this is the battery connector, and in battery connectors there is a positive pin number 1 and 2 is a positive, pin number 3 and 4 is a SM bus, and then pin number 7 and 8 is a ground. So this is a positive coming to the fuse. Here is a fuse PF1, and this is the output is connected to the battery. Okay, so 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 when the laptop need a charge, at that time we can see here in the concept, when the battery need a charge, the battery communicate with the buck boost converter. Then what happen is this buck boost converter switch this MOSFET, this particular MOSFET, and then the battery, the system voltage is passes into the battery, and battery started charging, and in this way this system work. So in this way the battery charge, and if the battery is absent, the power working on a adapter. So this is the output voltage and this is the battery connector. Okay, so I hope you understand this concept of the schematic diagram.